Hey, Will. So,
Very cool.
what are we up to?
We are gonna make a sound with this tool you made, which is really cool. So I guess we should start there.
Yeah.
If we could, if you could explain a little bit. I didn't even know, like from the tools menu in Kyma, that these are tools that have been made the same way you've made this. Like until you said that, that I never connected the dots on that. So
Yeah, yeah. So you
that's
can,
pretty cool.
yeah,
So yeah, if you could, Alan, take us through this,
take it away. Well, okay. Well,
through
let's
the tool and kind of what it does a little bit.
we should welcome our viewers that we hope
Yeah,
that we hope
yeah,
so.
that's
So
true.
welcome to we haven't got a name for this yet. Fireside Kima chat.
Fireside
Um,
Kima chat and coffee.
so and so the idea of this is we're going to set ourselves a little exercise to do, and we're going to do it collaboratively, kind of in and record it. With the hope that it'll be a bit of fun, and during the process, we'll try and explain what we're doing. It might be a learning opportunity. We'll probably learn something, and it'll be like an excuse to explain things about Kyma as we go. The way we're going to do this is we're going to run a tool. I've made a tool. There's a thing you can make in Kyma called a tool, which is a kind of small talk process which will run on your computer. And this tool will randomly choose the exercise for us to do. So we have no idea at this point what it's going to say or what it's going to ask us to do. And we're going to try and do this in about 30 minutes. So once we press the next button, it's going to kick off. And then we'll have like 30 minutes to try and come up with, well, you'll see. It's
Right. We'll sit once we have some guidelines there, it'll become
yeah.
clearer.
And I think yeah, the way I've loaded the tool up with gubbins, they're very much vague. The requests.
Yeah, that's what I was going to ask. Like, I see single EX there, so single exercise. That makes sense. And then we see sound. Uh,
Yeah, so what it does is it has these lists of different things and it can choose from them. And you can kind of enable or disable these lists that it's going to choose from. So sound is like, what kind of sound is it? Is it like are you trying to make a sound that's like watery or is it
or a
like
drone or something
or
like
a
that.
drone? Yeah, exactly. Or
Okay.
like a lead
And
synth.
you put those
Yeah, yeah,
names in there, right?
yeah,
Okay.
yeah. But we can put more in.
I see.
But
Yeah,
it's open to
it's adjustable. Okay, so that's what sound means. Control is like how we're gonna
control.
control the sound. It could be MIDI or it could be live input,
Exactly. Yeah.
something like that. Okay.
Um, and
Type.
then type. So type is like, is this like a sound in the sound editor, or is this a multi-grid, or is it a timeline, or what kind of a thing is it that we're kind of
What
making?
environment sort of thing?
Yeah.
Yeah. Okay.
Strategy. At this, I must admit that this is heavily borrowed from Brian Eno. So this is kind of like oblique strategies, kind of
Oblique strategy. Love it.
fund
Yep.
in there. So it will kind of give us some guidance in a vague way there.
Okay.
Class is where it will suggest a particular sound class, a prototype that we should use.
Okay.
And genre is probably self-explanatory. It's
Yeah.
genre.
All right.
So when we hit next, it's going to choose not necessarily all of these. It's going to choose some combination. It might just be two things. It might be three or four things from these lists.
Okay.
So it might tell us to.
So we really don't know what we're gonna get.
No.
We have 30 minutes. Yeah, it's very cool.
There might be like a timeline in the style of grunge rock. Okay.
Wow.
And
Okay, this could be tough. I'm realizing I tend to go to a certain area like in the flow. So
Yeah.
if this says timeline,
we're gonna be stuck.
I'm gonna be yeah, because you're not much of a timeline user, at least when
This is
we
where we
talk
come
about
back.
this.
We edit it afterwards.
Yeah, we just snip that portion out until we get something that we actually know.
If you see any glitch at this point, we cheated.
Yeah, exactly.
Not that one.
All right. Well, I'm ready when you are.
Okay, here we go. There. So our 30 minutes starts now, and our instructions are: it's a whoosh sound.
Okay.
The class is stereoizer, so we should use a stereoizer somewhere in it, and the genre is ambient. Okay, so it sounds like we're making a sound. So I'm going to make a new
whoosh.
sound.
Okay.
Any thoughts? We'll leave this.
Do we have to start with the stereoizer, or that just has to be in it somewhere? So we're free to do whatever at this point.
We're free to do. We could ignore this completely and
we could just do whatever we want.
Or we just do some four to the floor acid track instead and go, there you go.
Yeah.
But no, how do we want to interpret this? So something whooshy.
Well, we could start with noise. We could do some sort of filtered noise, or I could see if we wanted to synthesize, or I could see a live input.
Okay, well, I'll save this file first of all, just so we got it. Yeah, so we'll just call this Fireside 1. Okay. We got a noise. We've got our editor open. This is exciting.
We're on our way.
Yeah.
Nothing essential happens in the absence of noise.
So what kind of filter? I love the harmonic resonator. Can we bung one of those in?
Yeah, please.
What are we doing again? We're doing a whoosh. I don't know if it's whooshy. Is it whooshy? What about an all-pass filter?
Okay, yeah.
Okay, so
I'm thinking like I kind of want to drag my fingers on the continuum here.
Okay.
On a keyboard or something.
So if we put this into all-pass mode, right, and then mix that back in with itself. Like that.
So you just copy pasted that. Okay.
Sorry. Okay. Yeah. I'm racing against
No, it's brilliant. I'll follow it, but yeah, just in case people want to build it themselves.
One of us at least has to be talking out loud.
Yeah. Okay. So you started with noise, you added an all-pass filter after it, then a mixer, all of this stuff on the line after, not the plus, right? And then you copy pasted the noise. So the noise is being filtered and going straight to the output.
Yeah.
Yep.
And we can put like this scale. So we could put like this like a all pass level. So we've got some kind of like balance between.
Yeah, kind of a wet dry sort of thing.
Kind of wet dry. Actually, so what we could do instead is we could literally do that on a kind of crossfader. So if we get what's it called? Crossfade interpolate. Not crossfade. Crossfade interpolate N.
There you go.
I like better. Let's try. Now we have to drag that on the line, not the plus. Okay, now this one comes with a few things that we don't want. So we're going to replace that chop saw with the noise just by copying and pasting over it. And then just delete these just by pressing the delete backspace button. So we should have a crossfader. Actually, we don't need the mixer anymore. So we'll replace that with the crossfader by pressing delete, or backspace, I should say. So now we have a crossfader that should crossfade between noise and the all.
Right, it starts up top leftmost sound, which in this case would be the noise, and then the filter, right? So
yeah. So 0, if this wet thing is 0, then it'll be noise, and if it's 1, it'll be all filter. So we can make a 50-50 balance.
Right.
Now, we might want a level control on the end. Actually, no, I've got, what am I saying? I've got a knob right next to me, so I'll just fade it down. Okay, so 50-50. Bit subtle.
It's on its way to a whoosh.
Okay, so that's kind of like not done a lot for me. We could up the order. Not very whooshy yet.
It's not. It's not whooshy.
No, it's kind of garbage. So my kind of all pass filter attempt at kind of a whooshy phasery thing is like not working.
What if um
Resonance. Maybe we need to up the Q.
Yeah, it seems like we want a tighter band of frequencies.
Nah, that's garbage. How far can Q go up?
That's a good question.
It doesn't really say, does it?
Q is related to bandwidth for all pass filters. This affects the size of the phase shift on frequencies around the center frequency. Higher Q corresponds to a narrower band. Yeah, I like that idea, making it a fader.
Okay. Yeah.
Go more, yeah, go more filtered. So yeah, higher number on wet there. Try even, I wonder, because white noise is so broadband that if we still have some of that in with our wet, it's very hard to pick it out unless it's extremely resonant. So I feel like we need a like much wetter, like higher number there. Like you've got 0.79. Do you know what I'm saying?
Oh, okay.
Like,
yeah.
Like just, you could probably even have that like all the way up or almost all the way up. And we should be able to hear it maybe better now. And then with a higher Q.
That's not kind of working how I was expecting it to work. I think that sounds terrible.
It's got the timbre of a whoosh. It just doesn't have the whoosh of a whoosh. It doesn't have a, you know, the sort of the movement I associate with a whoosh.
We'd get more of a kind of, I mean, okay, let's try one last thing, right?
Yeah, let's stick with it. I mean,
so I'm going to get a cascading replicator. Now this might be just the same as like kind of, I'll delete all this stuff out. So we're going to cascade.
You're just highlighting and pressing backspace on that stuff, right? It's just,
I am, yeah.
Just losing it. Yep. Okay. And we've got 4 iterations.
So the cascade input should be this one, I think, if I remember right, how this one works. And the shared sound is that. Right, so what this does, this is like a replicator, but it puts one after the other. So it makes it, instead of like a parallel replicator.
Yeah, instead of like this kind of thing, it's like.
Yeah. So we'll make like 8 of them, and we'll put on rename special events so it won't rename anything. And I'll turn the sound right down.
Yeah.
Something violent.
Yeah, that was one of the first things I learned. If you're playing an unfamiliar sound, make sure you have the mute button underneath your fingers.
Now, this is like really terrible. This is just... I've obviously just remembered something completely wrong.
I wonder... I mean,
we do something else then.
Why we're not... I think we can still start with noise, but... Yeah.
Do a bandpass filter instead?
Yeah, I could see a version where we like use key pitch as our frequency, and that way like we could, you know, on here like the continuum, I could start low and kind of get this whoosh from low to high or high to low based on the key pitch.
Well, should we put, how about so what, harmonic or bandpass? Because we could put bandpass in.
Yeah, since you got it there, let's try that.
Okay, so like in Kyma, the bandpass is actually, so we'll get rid of this one because that just didn't work out. So it's a high pass followed by a low pass. Now the high pass can kind of blow up, especially if we start putting feedback and stuff in here. So a little trick we've learned is to divide this, because one thing in Kyma, right, that's kind of cool, is we have tons and tons of resolution. like it's 32-bit, right? So like CDs are what, 16-bit, you know, so like 32-bit is an immensely tiny number. So you can actually, a thing that you can often forget is that you can attenuate signals massively in Kyma and then multiply them back up again afterwards. And you don't lose as much as you think. So like we can literally lose 7 bits off this. Well, I mean 8 bits if we want, but we could lose 7 bits off this by just scaling this thing right down. So we just go 128 inverse. And so that's going to divide the volume going into this filter, this high pass filter, by 128.
Okay.
And then on the output of this, we're just going to gain it back up again by 128. And that keeps it really well behaved. And we're losing 7 bits of data, but off 32 bits, it's not, you won't hear it.
Okay, interesting.
And it keeps it really well behaved. Now the cascading replicator is set to 8. Let's set it to kind of just something like 1 to start with. And we've got band. Let's see what this does. Okay. Oh, it's getting a bit more whooshy. Yep. That's more.
There we go. Yeah, that's what I was expecting from the start.
So we could, again, mix a bit of the original back in.
There we go. Mm-hmm.
We can put a bit of resonance in.
Try slightly lower Q, if you would, please. Yeah.
I like it. Okay. So I'm going to just press Command and click on this snapshot, and it'll override the default.
There we go.
So when we restart, we'll start there. Cool. Should we see how much time we've got left?
Yeah, let's check on the time.
17 minutes, 8 seconds. Okay.
To go. Okay, so it's counting down. Is that right?
Yeah.
Okay.
I remember right how I did this. Yeah. Yes.
There we go. Yeah. Yeah. Perfect. Okay, so we're halfway there and on time and goal.
Yeah.
What might happen if we increase that replicator number?
Who knows? It might be kind of the same as like upping the order, but let's try it, see what happens. Just kind of kills it.
Yeah, what happens if it's, yeah, there we go, higher what?
I guess it's like a bandpass on a bandpass at this point, so it's sort of yeah, do you know what I mean? It's bandpassing the bandpassing, so the amount of signal pass through is just getting lower and lower.
Yeah.
So a cascading replicator on a bandpass seems like a boring idea. How about a standard replicator?
You know, I was thinking, like, what if we do that and then just like offset
each one
a little bit, you know, and if we get this, and there you go, yeah.
So I'm going to drag and drop a replicator, and then we'll get rid of this cascading one. Delete, replace, make sure it replaces with the correct one. Otherwise we lose stuff. And we can make noise our shared sound, which is what this 0 is here. If we open up replicator, we should see, yeah, noise is shared. Okay, so we're going to rename special events, meaning we won't rename anything. So we'll just get one set of controls.
Yeah, the Capitalk event values in red, right? Yeah.
Yeah, exactly. Yeah. And we'll start off with 4 copies. Cool. Right. All right, we got the amp. So this amp low is the level coming out of the replicator.
Right, it's like a master fader. There we go.
Okay, so at the moment, all of those are set to the same frequency. So it's just 4 copies.
So what if you, I'm thinking, man, I really want to just take 5 fingers a little bit spread here and just like this. You know what I'm saying?
Yeah.
But what could we do To
Well, you could do that with a MIDI voice, I guess. And then you'd have like polyphony.
what kind of controller do you have right there that we could perform this? Do you
I
have anything that's hooked up? MIDI keyboard even? I mean, you could do,
I got a MIDI keyboard.
yeah, could do something like that. Or I'm just thinking, I mean, a fader's fine for now. We could, if we have a few
I mean, we could detune.
frequencies.
We could
Yeah,
detune
detune it,
them,
exactly.
couldn't we?
That's all I'm looking forward to do is like have just enough variance there
Okay.
between
So
replications of the frequency.
we'll wrap the frequency field in parentheses.
Mm-hmm.
And then so this is in frequency. So if we want to manipulate frequency, we might want to, I tell you what we can do. Here's a cool trick, right? So this is in hertz. So if we cascade the units hertz to NN, we're now in logarithmic, we're now in note number, which means we can add them. So if we added 12, we'd go up an octave. If we subtract 12, we'd go down an octave, which is great for modulation, because like if we keep it in hertz and we wanted to go up an octave, we'd have to multiply by 2. And if we want to go down an octave, we'd have to divide by 2. We'd have to like multiply by a half. And so it's a bit harder to do. But this means that we can just do a simple add detune to this, and we go up and down. If we add like a detune, well, we could even say, if we say 1 is an octave, we could do detune times 12 because it's in
I
like
prefer pi. Remember our pi tuning is an octave? I'm just kidding. All right. Yeah. All right. So detune times 12. All right.
So detune times 12. So that means if our detune fader goes up to 1, it's actually going up to the number 12, and 12 is in note numbers, so it's gone up.
So it'd be up an octave.
Yeah, yeah.
I'm with you. Makes sense.
It is an octave. But what we can also do is multiply that by voice number. Now we want the first voice, because we're replicating this 4 times. We want the first voice not to change. There's no point in detuning the first voice, because what we detune.
Yeah, you need a reference point.
Yeah, I think so. So we'll go voice number -1. So we don't detune the first one.
Okay.
And yeah, and we don't need to convert back to hertz. That's fine. So we can just copy that and go to the high pass filter. Do the same. There we go. Do you see what that does?
Let's check it out.
Okay. Getting a bit whooshier.
Yep.
Like,
I wonder if we need.
It's not very stereo yet. So stereo.
Oh, we haven't even gotten the stereoizer involved. We've broken the. Yeah, now is the perfect time for that.
It was, yeah.
We only had 3 things. All right. Yeah, we have time.
Just try and follow the instructions, right? So that's the crossway. So we'll put the stereoizer in front of it. Now, what does a stereoizer do?
Great question.
So the stereoizer stereoizes.
Right, it takes a mono signal and then adds some.
Yeah.
Duplicates it or something. It probably says up there, and then adds.
So again, I'm going to check rename special events so it doesn't create duplicate controls. So we just got 1 set of controls so far. Now it's going to duplicate the whole thing and make a left and a right. Now, if you remember, Replicator creates a voice number that we used in here. So like that voice number goes 1, 2, 3, 4 for the 4 replications of the Replicator. Stereoizer, I think, uses channel number. It's down in the help down here. Yes, you can use channel number to refer to the destination. So that's cool because that won't clash with the voice number that's being created by Replicator. You can make it use voice number if you check that, but we won't. We don't want to do that. So how do we want our two channels to be like different? We could detune it in the opposite way.
Yeah, I was gonna say, yeah, something like detuned like that might be nice.
So okay. So I'm now trying to think. There's probably I'm trying to think of some quick math that would do this. So basically, if we take the channel number, and we want it, well, because we know it's only two, right? It's just channel 1 and channel 2, right?
Right. Yeah. Yeah. Yeah.
So if we if we subtract 1 off that, it's going to be 0 and 1, right? -1 and 0. So we want to minus 2. so at the moment it's like 1 and 2, right? If we minus 2, it's going to go from -1 to 0. And if we multiply that by 2, it's going to go... No, that's not right, is it? Because that's going to go from -2 to 0. No. That's no. Try again.
So channel number is either a 1 or a 2, is what you're saying.
Yeah. So if we multiply it by 2,
and then we're
it's now going to go
by
2 to 4, right? And then if we subtract 4,
we're now -2 to 2.
-1. Okay, so now goes 0 to 1. Right, we got that. Okay, come on. Maths under pressure. It's going from 0 to 1. Now we want to multiply that by 2. It now goes from 0 to 2, and then we subtract 1. I'm sure there is a quicker way of doing that, but why is it not like that? What have I done? Oh, because we need to
something.
Multiply it by that. Might have too many parentheses in here. So basically what we're saying is we multiply it by -1 or 1. So the first channel is going to go down and the second channel is going to go up.
Sounds good.
Okay, so now
I hope.
Yeah.
We'll see. Theoretically, it sounds good.
Yeah, that's good.
So, okay, and you're putting it in both sides. Yeah, makes sense.
Yeah, I'll put this in the high pass as well. Okay. Right. So left's going to go down. Let's see if it works. Oh, it's kind of lost all our settings.
Oh, it did. Yeah, Q. Look at Q is really low.
Okay.
Yeah. Okay.
Okay. Oh yeah. I'm not sure. I don't know if this is recording in stereo, but that's going pretty wacky.
It's very vocal, actually. What happens with a slightly higher Q?
Oh wow, that is like really freaky.
Synthesizing voice. Yeah,
like, right.
I'm not hearing it in stereo on my end, but I can. Even without it, I can tell it's intense.
Let me try. I think I can. Hold on. If I get the where's the little menu? If I go and turn on original sound. Now you might get a bit of echo from you now.
It just spread.
Did it? Oh, okay. So hopefully this will record in stereo now. Are you getting the
I'm in stereo. Yeah.
Good.
Very nice. And can we get a frequency sweep?
I think we need to get a frequency sweep. We got 4 minutes left. So, how should we do this? I mean,
I could see like an exponential function.
Mm-hmm.
So, could we just make like sound a global controller? And How can we get a exponential wavetable and then map frequency to that?
So what, like use the sound to global controller and kind of animate it?
That's one thought I had, yeah.
Yeah, cool. Sound to globe. Now I have to remember to type these all out properly because I've renamed them all for myself.
Oh, have you? Okay.
Yeah, I've made little abbreviated forms so I can type them in.
But how do we, I'm thinking the function generator might be an option too, but let's check this out.
Oh yeah, well,
you know what I mean? We could just load an exponential wavetable.
Oh, I see, right.
Generator.
Oh, okay. Function generator. And no, so we'll go to Kyma waves control. Have you got one in mind? Exponential.
There you go. Mm-hmm.
Okay. And what should trigger it off? Key down. And what's our on duration? Should we make it key velocity or something crazy?
On duration, key velocity. Okay.
So key velocity is going to be what, a number between 0 and 1. So we times that by
a quick 3
length.
Or you're going to length, yeah.
And then make that seconds. Okay. So we got this function generator. Oh yeah, and that's going to go into the sound to global controller, and that's going to, what are we going to affect again?
Frequency.
Frequency. Okay, so this is going to be a number coming out from like 1 to 0 or something. So what range of frequency do you want this to?
What does the frequency fader? It goes from 0 to 10,000. Is that right? Like just by default, if you just type frequency,
yeah, say it goes from 0 to 10,000.
I don't know.
Well, so we can add it to a base kind of frequency. So we've got like a thing that we can kind of muck about with. And we need to like multiply this by 5,000. No, let's say call it. Let's call it env.
Okay.
Times by 5,000. So we've got this kind of control about how much. I mean, we don't need the parentheses or anything there, but okay. So that's going to control the frequency. So here's our. That's the amount that the envelope is going to do it, and here's our base frequency should be in hertz. So we want that to go up to say 5,000. So we should be able to change. Okay, now if we hit the keyboard, oh, I think it's like going down. This function generator goes down, not up.
Let's see the wavetable.
To see the wavetable, we press.
There's reverse. Control click that.
Command click. So it looks like it goes up, and yet it sounds like it goes down. We take that. Oh no, but it ends high.
Yeah, it ends high. So
maybe that's right. Change range. Let's go up to 10 seconds. I don't know.
Thumbs up. Pencils down.
Pencils down.
All right, let's finish our thought here, and then I think we can call it a success.
Sure. So the on duration, I don't think so. You can't. Oh, you can reverse. I think we can reverse it.
There you go.
So we could try doing it the other way. We got that thing doing our frequency with that length, I'd say we just like copy that. I'm going to do a Command C, do a Shift Command V to make a copy into the mixer. Yeah, exactly. Sorry, I've mapped that to Shift Command
instead
V.
of being the same sound global control, you duplicate it.
Yeah, exactly. I did a paste special, which I've mapped in the system preferences to Shift Command V. But you're quite right. That's
okay. Cool.
That is. So we've got. So we could just use another waveform, Gaussian or something. So we got, and we could have this length times, I don't know, 2. So it's different, but it triggers off the same event, and that will swoosh the what's the other, detune.
Yep.
And so we want to
not detune depth, was it? I think it's detune.
Oh, you're absolutely right.
Filled in there.
And so again, we'll multiply that just by env to sort of say like how much you want it to be done by that, and then we multiply that by the kind of base detune amount. So like if we have like no detune, then it won't sort of do anything. I don't know, maybe we should have, anyway, there you go. So a base detune is like, so you can see that our frequency is doing one thing and our
yeah, try shorter length, seems to be more compelling with the shorter length.
Ooh, the detune's not doing very much. What's that? We're multiplying the function generator by the envelope by the base detune. Oh, because the envelope's not doing very much. Fair enough. Oh, there we go. Oh, stereo whoosh.
Yeah, I like it.
Here we go, yeah.
Very nice. Great work.
Well, there we go. For half an hour.
Half an hour on the fly.
On the fly.
Very cool.
There's our sound.
Great work, Alan.
Make it glorious and large. So, not too big. But we use the stereoizer.
Can we see the tool again?
Yeah. There's our tool.
So we made a whoosh. We use a stereoizer, ambient.
Is it ambient?
I think it's fair. Yeah. And we did it in a little over 30 minutes.
Yeah. I think if we replicated it and put it through a reverb,
it'd be pretty fun, pretty cool.
It'd be amazing.
All right. Great work. Let's do it again.
We'll do that again. Thanks for helping out. We'll kind of swap over next time.
I'm not sure what I did, but it was fun.
It was fun. We did some stuff there.
Yeah, absolutely. No, thanks for having me. Thanks. I think it's a very cool way of doing things.
Yeah. Okay. Cool. Well, next time we'll share your desktop, and
sounds good.
I'll shout at you.
Yeah.
Left a bit.
Looking forward to it.
Cool. Okay. Well, we'll review this back. If it worked, we'll do it again. And who knows what the next fireside challenge will be. Cool.
Only the tool knows.
Yes, only the tool. Great to see you up.
Yeah, you too. Thanks again for having me on. A lot of fun.
See you later. Okay.
Cheers.
Bye.